To go along with our recent bender reviews, I wanted to show a terrific piece of software that will help you to make better bends with less waste. Bentech software makes a package called Bentech EZ, EZ3D Pro SE, SW, which works with SolidWorks, and they even have a sheet metal module. All of these programs can take hours off your production time and minimize the amount of thinking that you have to do in order to get a proper bend. Whether you're building a single project or building chassis for a living, the Bentech software will streamline your workflow and cut your waste to virtually zero. When you start the program, you're presented with the initial screen where you can choose from a variety of templates. If you look over here, you'll see custom part, custom 3D part, assembly, hoops, door bars, offsets, single bends, U-shaped, on and on and on. Virtually any bend that you're going to need to make is contained here in these templates. Now, if there's a part that you have to make that doesn't fall into one of these template slots, you can then even create that either using custom part or custom 3D part. In this demonstration, we're using the Bentech Pro. If you bend more than 2 tubes a year, this is the software you want to get. It's $275. It's extremely affordable, and the money it's going to save you in time and effort and not having to strain your brain or waste pencil lead trying to figure out how to do a bend more than pays for itself the first time you fire this software up. So get it and don't even look back. Don't even bother with any of the entry-level stuff. Just go for the Pro and you'll be very happy and glad that you did. Now, before we do anything, I want to go into the Tools drop-down and go to the die library. In the die library, it's simply a list of all the dies that you currently use. If you look, you can enter a new die. If you buy a new die, you just simply enter it and add all the numbers that you have to associate with that particular die. If you notice here, I have 1.5" by 5.5 true calibrated. Well, now I entered that true calibrated when I gave it the name, and that is simply a function of the calibration. Now, when you buy a die, it's 1.5" by 5.5" centerline radius. You want to calibrate that to find out what the true centerline radius is. And in order to do that, they have a very simple method of calibrating your die. You click on calibration. You choose the model of the bender that you are currently using. In our case, we're using a JD Squared Model 4. And you simply follow the directions. To calibrate the die, you take a piece of tubing of a known length. You mark a location on that tubing. You bend that tubing to 90 degrees, and then you measure it. Once you've got those numbers, you simply come down here, you enter the initial die centerline radius. In our case, it would have been 5.5 inches. The outside diameter of the tubing that you were using, the cut length, the length of leg 1, the length of leg 2, and your mark location. Once you've entered those numbers, the centerline radius, calibrated centerline radius, and bend location offset are automatically calculated, and you can then turn around and consider that your die is calibrated. This will give you extremely accurate bends and minimize your waste to really, literally, virtually nothing. So once you've done that, you can then go in again to the Tools menu and go to the Material Library. As was the case with our die library, this is merely a list of all the material that we currently use. The nice thing about this is you can enter new material, click the Add New button, enter the wall thickness, the diameter, give it a name, and if you know the weight per inch, or if you're working with metric, the weight per millimeter, and that should easily be available, that information is available from your supplier, you enter that there. That allows the program to calculate the actual weight of your finished product. This is very handy to know how much is my cage going to weigh, how much is my roll bar going to weigh, or what's going to be the weight of my component that I'm going to bend up. So once you do that, you're good to go. Then you can simply choose it. You can also set any one of these materials as your default, as you can with the die. What I like is that you can color code the different sizes so that visually you can tell the difference between a piece of 1.5" 109 wall and 2" 250 wall. Very, very nice and really simple to use. So now we'll go over here and we'll make a very simple hoop. If you look, there's little plus signs next to a lot of these templates, and that just tells you that you have some sub-menus. You can go to a simple hoop, single bevel, double bevel, door bars, etc., etc. There's more as we go deeper into the menu. Now if we take our double bevel hoop, we can choose to use center dimensions, outside dimensions or inside dimensions. For this demonstration, I'm going to do a double bevel hoop using outside dimensions, and when we click on that, we come to another menu. Now if you look over here, you'll see some tabs. Now these are very helpful to have. Now the die, we have set our die to be 1.5", 5.5. That's our true calibrated die. That's going to be our default. You set that up when you initially set up the software. And our material is going to be obviously 1.5" by 109 drawn over mandrel mild steel. And as you can see, we have our diameter, our wall thickness, and our weight per inch. That's going to come in very handy when we finish producing the template for our particular bend. Now we're going to enter some numbers here. We're going to make this 50 inches wide, top and bottom. We're going to have a 36-inch center bar. We're going to have 35 inches from floor to the top of the bar, and we'll say 12 inches from the first bend to the top of the bar. Simply by entering those figures, you can see over here we have a graphic representation of the bar, and up here in our bend box, it shows us not only the angle but also the location. So when we mark our tubing, and up here we have our cut length, 107 5/16 of an inch. Our weight will be 14.5 pounds. This is giving us a tremendous amount of information that you just don't get anywhere else. You're certainly not going to get this if you're doing this on a pencil and a piece of paper. So our bend location, we make our first line at 27 7/16. We'd bend it to 30 degrees. And as we've calibrated our spring angle on that particular die, we know that to get 30 degrees, we have to go to 43 degrees. There's a lot of spring back in this particular piece of steel. That, if you enter your spring back figures on two angles, let's say you bend one 45 degree and one 90 degree test piece, enter those two numbers, and it will automatically, the software will automatically calculate spring angles for every angle up to 180 degrees. So it's really quite handy. It takes all the guesswork out of things. Now over here you'll see this little tab says cutoff. Now I add an inch in the front and an inch at the back. If you take them out, take a look at our cut length, and you'll see that our numbers change. Always good to have a little bit excess. It's easier to cut off than it is to weld back on. And our simulation over here, now on the Model 4 the die doesn't rotate and the bend direction is clockwise. So we click clockwise. You can see counterclockwise or vertical. Some benders are vertical. And our die does not rotate. So you have die rotation or without die rotation. In our case we do without die rotation. And then we can run a simulation. Simulation merely shows us what the bend's going to look like as it goes through the bender. Now this is our speed bar. We'll slow that down a little bit so you can see this. And we can run our simulation. Now on a flat bar like this, that's not really that important. It's kind of cool to see it work, and it lets you know, okay, everything's working fine. If you were to do a bend that required a rotation, in other words, you had to make your first bend and then rotate a specific degree to make your second bend, which is often the case when you're doing A-pillar bars, that would also be visible here, and that can be a big help, especially if you say view straight on, click on the location, and you will see now on our flat bar this is the representation of the tubing, and this is the representation of the die. But on a rotated piece, this tubing might go down or it might go up. So that helps you to orient yourself in position when you're doing this kind of bending. So once you've made your bar, you can save this part and add it to your library of saved parts. If you ever have to come back and make this particular bar again, you've got all your numbers right there. This will print a setup sheet for you so you can take that out to the shop and you can tape that right up to the bender, and you'll know exactly where you have to go and what you have to do. Now once you've done a number of bars or door bars or A-pillar bars, B-pillar bars, whatever you need, diagonals, you can put them all together in an assembly. Now I have a assembly saved here on a 240SX that we did. That is a full cage, and as you can see, we'll just make this a little larger. Now some of these dots might not make any sense to you, but they all have a purpose. Now what's really nice is you can do a wire mode, so you can see a visual representation. And in the Pro, again, you have the capability to rotate the model in 3D space. And that's really nice because you can look and you can see conflicts, or you can see, okay, I like the way that works, or I don't want that bar in that particular spot. As I was talking about rotation before, these A-pillar bars are a perfect example of that because they needed to be bent and rotated. That was very, very simple to do, and by following the instructions that were generated by the program, we made perfect A-pillar bars. Now if you want to really show somebody something, you just go to Model Shade. This gives you a beautiful 3D rendered representation of your part. And we'll just shrink that down. And if this doesn't impress a customer, then I don't know what will. But this is really, really fantastic feature of this program. It allows you to really visualize what your piece is going to look like, and you can't ask for nicer than that. This is really high-end professional graphics, and I understand they're actually working on even better graphics in the next release. So I don't know how you can improve on graphics like this, but this is really, really terrific stuff. You can verify your dimensions. There's a verify. You can run dimensions so that you can actually generate a print. This is top of the line software. Now you can have the best software on planet Earth, but if the customer support is lousy, it's really not even worth the price of admission. Happily, I can attest to the fact that the software support from bentech is absolutely exemplary. When you call them up, if you have a question, you will most likely get to speak to the designer of the software, the programmer, the fellow who actually built this product. And he's extremely knowledgeable, obviously, and very, very easy to speak to. He speaks in English. He doesn't speak geek speak. I guess if you speak geek speak, he would probably speak it with you, but he will absolutely tell you where you made your mistake, and guaranteed when you call with a problem, it's most likely 99% of the time because you made a mistake. Don't ask me how I know that, but take that to the bank. Excellent customer service, excellent software, really, really affordable, and I cannot speak highly enough of the bentech software family. I'm excited about it. I can't wait to see what else they come out with. I understand they're coming out with, or already have released, software that'll help you bend up headers. I can't wait to see what that's all about. For now, if you have a bender and you don't have this software, you're working way too hard. Bentech software, check them out, www.bentech.com, and just search for bentech on the internet and you'll find them. And tell them that you saw it at hre.com, and everybody will be happy. Great software, great price, buy it.